Hey everyone, this is Mr. Geiselman. I'm about to walk through the velocity lab with everybody so we can get this done, and hopefully you can do just about the same thing that the kids in class are doing. So we're about to start. Here we go. So in the velocity lab, what we'll be doing is we'll be taking our CPO equipment and we're going to be using it to calculate the speed of a car as it travels down a track. Now what we'll do is we'll have two photo gates on, both of them will be on, and we are able to find a time from there. And we're going to set them a certain distance apart, and we're going to let the car run through. Our time shows up on our photo gate timer, and now we're going to do this 6 times for every spot. Once we've done our 6 trials, we're going to find our average time for that distance. And then we'll take our photo gates and we'll adjust them by moving them 5 centimeters at a time. Now we'll do another 6 trials at this spot, and we're going to figure out the speed using that data. Okay, so we did all of our tests. So you guys don't have to sit there and watch me do all these different tests, but we have 5 data sets ready to go. All right, so our first question that we need to answer before we can really look at our data is when both lights are on photo gates A and B, so both photo gate lights are on the timer, what does that indicate about the car's motion? So what does that data that we get indicate about the car's motion? All right, you should remember this one from investigation 1A. So answer the question. Good, you chose that's the time between photo gate A being tripped and photo gate B being tripped. All right, so nice job. So that brings us into our data set. So our first data set tells us that we have our distance from A to B is 65 centimeters. And here are our time trials. So for our times, right, this is right here, and we averaged 0.99 seconds. Using that information, our distance and our time, calculate the velocity for the data in data set number 1. All right, the first time you're going to do it in centimeters per second, and you're going to use this formula. All right, figure out our speed in centimeters per second. All right, now the next step is to calculate that velocity in meters per second, because that's what we use in real life, is we use meters per second. So calculate that data and tell us what the answer is in meters per second. All right, moving on. Data set 2. In data set 2, we reduced that distance to 60 centimeters, and our time's adjusted a little bit with an average of 0.95 seconds. So we have a new distance and we have a new time. Your first job is to calculate the velocity for data set number 2 in centimeters per second using this same formula. Go ahead and do that. Next, all right, you should be calculating that data, or using that data to calculate the meters per second for data set number 2. And again, use V equals distance over time. There you go. Data set number 3, we reduced it again by about 5 centimeters, and now we have some new data. All right, our average time dropped to 0.89 seconds, and our distance is now 55 centimeters. So calculate the velocity for data in number 3. All right, first off, doing it in centimeters per second. And then, once you have done centimeters per second, we're going to hop ahead and do our velocity in meters per second using that same formula. Data set number 4, again, we've reduced that by 5 centimeters. So our distance is 5 centimeters smaller, and our average time has dropped to 0.84 seconds. Calculate that velocity in centimeters per second. and then calculate that velocity in meters per second. One more to go. We have data set number 5. We have now reduced this to 45 centimeters. This is the smallest we're going to get. And our time has adjusted to 0.78 seconds. So calculate that data set's velocity in centimeters per second using velocity equals distance over time. And now do the same thing for that data set, but in meters per second using velocity equals distance over time. So this brings us to question number 2. All right, so if we're using the velocity from data set number 1, how many meters would the car go in 8 seconds? All right, just a reminder that data set number 1's velocity is equal to 65 centimeters per over 0.99 seconds. And again, you need to figure this out in meters per second, or sorry, meters, excuse me. So you'll have to find it in meters per second. All right, to do that, find V and then rearrange the equation to solve for distance, just like you would do in algebra class. All right, ready, set, go. Question 3, and this is the end of it, all right? This is our last thing. Using the velocity from data set number 3, how long would it take for the car to go 100 centimeters? All right, here's your data from number 3. Find that velocity and rearrange it to solve in the equation to solve for time. All right, so good luck, everybody. Hope this was an easy to do video and we've got some good answers. Have a great day.